All right, welcome back to another video. In this video, we're going to be looking at BGP authentication. So it's so that not just anyone can form a neighborship with you. That person has to have a special code in order to do that. So BGP protocol exchanges can be authenticated to guarantee that only trusted routing devices participate in autonomous system routing updates. By default, authentication is disabled. So if you're in a secure department, working for a bank, working for the government, something, probably going to see something like this set up. And really, something like this, like, probably just set it up anyway. As long as you're a professional, competent network engineer, just slap authentication on there. I mean, there's kind of, you keep the noobs at bay doing that, and you have that extra security on your router. You will kind of make it harder for yourself to figure out what's going wrong. So if you're in the lab and you're just trying to learn about certain stuff, I wouldn't put on extra stuff, but I really wouldn't be surprised if this is a really large part of a professional network engineer's job, especially for working for companies that have security as a really high concern. So when you configure authentication, the algorithm creates an encoded checksum that is included in the transmitted packet. And we'll be able to sniff that out with Wireshark. I'll make sure to do that after the configuration of this is in place. The receiving routing device uses an authentication key password to verify the packet's checksum. So we'll take a look at that as well. This example includes the following statements for configuring and applying the keychain. Key, a keychain can have multiple keys. Each key within a keychain must be identified by a unique integer value. The range of valid identifier values is from 0 through 63. The key can be up to 126 characters long. Characters can include any ASCII strings. If you include spaces, enclose all characters in quotation marks. So I probably won't read all of these. Well, I might as well. Tolerance, which is optional. For each keychain, you can configure a clock skew tolerance value in seconds. The clock skew tolerance is applicable to the receiver accepting keys for BGP updates. The configurable value is 0 through 999 million, actually, 999,999,999 seconds. So quite a lot of time. I mean, this is almost 1 billion seconds. Let's take a look at how long 1 billion seconds is. I'm kind of curious about that. So 1 billion seconds is about 4 months shy of 32 years. So I don't know why you'd want to have the same password for 32 years. It seems kind of a funny upper end for that. But hey, you're good for 32 years if you set the tolerance to 999,999,999 seconds, or 999,999,999 seconds. You set it to that, you're good for 32 years. Keychain. For each keychain, you must specify a name. This example defines one keychain, BGP-auth. You can have multiple keychains on a routing device. For example, you can have a keychain for BGP, a keychain for OSPF, and a keychain for LDP. And off the top of my head, I don't remember. I think this is, it's Discovery Protocol. I just want to look up quick what LDP stands for. Label distribution protocol. Okay, that makes a lot of sense because MPLS has got a right on that. So yeah, you've got LLDP, of course, but that's completely different. It's a link layer discovery protocol. It's like CDP. That's one of the things one of my pet peeves in kind of a professional environment is you'll hear people get lazy with LLDP and they'll start calling it LDP. And it's like, dude, like LDP is its own thing. You can't just call LLDP LDP and have people know you're talking about LLDP. So anyone of this channel, that's my advice to you. Don't get lazy. Use the correct terminology because you really want to have the respect of coworkers who really understand that there is a difference. That's important to use the correct language, take that extra step. And you can even say like, you know, because if you're sick of just saying LLDP, why do I need to do that? That's annoying. You can just say discovery protocol or you know, you can narrow down the context in that way. But to just drop the L and just say LDP, that's a big pet peeve of mine. And unfortunately, I was in a situation where I used to hear that just about every week, and it drove me nuts. So just kind of something for viewers of this channel to be aware of, that when you don't use the correct language and you kind of stumble over words. Yes, that happens to everyone. You know, watching this channel, I do that all the time. But to do that as an abbreviation, as something, oh, I'm sick of saying LL, so I'm just going to say L. You're colliding into things that are already defined, and you're going to confuse someone. They're going to say, oh, why is LDP not working? You know, you've got somebody like me thinking, oh, well, he's got an issue with MPLS. Like, this is a big issue. Like, oh my God, this is huge. And then, you know, it's revealed to you that they're just talking about LLDP. And it's like, oh, well, does it really matter? So don't give anyone heart attacks unless it's important that they have heart attacks. All right, so this is label distribution protocol. Secret. For each key in the keychain, you must set a secret password. This password can be entered in either encrypted or plain text format in the secret statement. It is always displayed in encrypted format. One thing that's kind of interesting to know in Cisco is these keychains and secrets are using Cisco 7 encryption. So Cisco 7 decryption is so insecure. You can just open a reverser like here in Packet Life, and you can just put in the hash, and every time you can just get the reversed hash. So Juniper, I think everything's in a MD5 hash. So it's much more, I don't know whether or not it's MD5 or some variant of SHA, but in any case, it is much more secure than anything on a Cisco. So Juniper's another really good job they did on their CLI. They have much more secure ways of storing passwords in their configurations. Start time. Each key must specify a start time in UTC format. Control gets passed from one key to the next. When a configured start time arrives based on the routing device's clock, so you gotta make sure you've got NTP set up, something that makes sure all your clocks are accurate. The key with that start time becomes active. Start times are specified in the local time zone for a routing device and must be unique within the keychain. Authentication Keychain enables you to apply a keychain at the global BGP level for all peers, for a group, or for a neighbor. This example applies the keychain to the peers defined in the external BGP eBGP group called EXT. Authentication algorithm. For each keychain, you can specify a hashing algorithm. The algorithm can be AES128, MD5, or SHA1. So you can see here, these are much more secure than Cisco 7. So they don't even give you the option of, well, you can probably put it in plain text, but all of these are going to be fairly secure at some level. You associate a keychain and an authentication algorithm with a BGP neighboring session. This example configures a keychain named BGP-auth. Key 0 will be sent and accepted starting at, oh, okay, so that's a time in UTC, and will stop being sent and accepted when the next key in the keychain, key 1, becomes active. So we're going to need to make sure in our example here that we are basing it on the clock that is actually configured here, and not just what is shown in the example. Because if we just use this and our clock, you know, it says 2011, it's kind of a little bit of a tell. It says now 2020, so a little bit out of date. Kind of a glimpse into when this was written, but you can see we'll stop being sent and accepted when the next key in the keychain, key 1, becomes active. Key 1 becomes active 1 year later and will not stop being sent and accepted unless another key is configured with a start time that is later than the start time of key 1. Clock skew tolerance of 30 seconds applies to the receiver accepting the keys. During the tolerance period, either the current or previous key is acceptable. Okay, that's interesting. The keys are shared secret passwords. This means that the neighbors receiving the authenticated routing updates must have the same authentication keychain configuration, including the same keys, passwords. So router R0 and router R1 must have the same authentication keychain configuration if they are configured as peers. This example shows the configuration on only one of the devices. Okay, so this is going to be kind of a good exercise to kind of figure out what that other configuration is going to be. We're only going to be given it for one side, so we'll need to dive in and figure out how to do it ourselves on the other ones, and then hopefully we'll see that form in the Wireshark capture. So to quickly configure this example, copy the following commands, paste them in a text file, remove any line breaks. So we're not going to do that. We're going to do it the unquick way. And I think, yep, so the unquick way are going to contain all the same configuration in the quick way. But let's go ahead and jump on router 1 here and start entering in those commands. You can see in between videos, I set it up to be ready. So let's go ahead and enter those commands. So start by setting the local autonomous system. And this is going to be an eBGP connection. So we know that the autonomous system of R0 is going to be different. All right, so now let's configure our external BGP group. So here we have a clue into what the configuration is going to be on R1. We know the autonomous system of the peer is this. So we know this command is going to be that instead of this. So edit protocols, oops, let me go back to the top, edit protocols BGP group EXT, set type external, set peer AS 65530, set neighbor 172.16.2.1. So now let's go ahead and configure authentication with multiple keys. So unfortunately, I have heard that this is very much dependent on the OS version you are using. This can be different from version to version, but this is kind of a consistent with that running theme of this channel, that the most important thing is that you know how to use your question mark and that you understand the concepts behind the commands, because you're not going to get the exact same commands every time, OS version to OS version, device to device. So just kind of understanding those upper level concepts of what a key is, a keychain, a secret, tolerance, start time, all these sorts of things. The algorithm that you use, the authentication keychain. So it looks like there's two different kinds of keychains, authentication keychain and keychain. Just understanding what those mean really well is far more important than understanding what the commands are, because the commands are going to be different from version to version, but the concepts are for the most part going to be the same. And you will have some exceptions to that, like, for example, the concept of IGP, so an internal routing protocol. So I'm just trying to think of what the G stands for in IGP, internal something protocol. Oh, gateway. Yeah, internal gateway protocol. Gateway is kind of like another word for routing. It's like a gateway is kind of like another word for a router. So interior, and it doesn't stand for internal, it stands for interior. So interior gateway protocol. Yeah, you can know what that means conceptually all day, but when it comes to a Cisco and when it comes to a Juniper, you're going to have pretty substantial differences if you use vendor implementations. Like Cisco has EIGRP. I think now it's an open standard, but for a long time it was a vendor implementation of that. So certain vendors will have their own proprietary versions where, yeah, you're going to need to kind of learn that, and just having an overlying concept of what a interior gateway protocol of what that is, just kind of knowing what that is isn't really going to help you implement any specific version of it. So let's keep moving. BGP auth. So this is, and let's take this more slowly and question mark out each of these commands. So security, let's get the help menu, security configuration. Let's get the help menu for authentication key chains. So this is going to be authentication keychain configuration. All right, so let's see what our other options are here. Just keychain. What about our other options under security? So looks like our only option is authentication keychains and keychain. So next command is going to be BGP auth. Let's see what other options there are. So this is just going to be the name of the authentication keychain. So BGP/auth is the actual thing we are creating. This is the name of the keychain. So let's configure the keychain. So we're going to set, looks like we're going to have multiple keys within the keychain. So let's set key 0, and let's see what else we can do besides that. So here we can set up our optional tolerance. We can give it a description, or we can inherit configuration that we applied earlier in a apply group. Or we can inherit configuration except for what we applied in the apply group. And these are going to be available in every location in the hierarchy of the configuration of Juniper. This is a feature you'll probably see taken advantage of. Has its advantages for sure. Me coming from a Cisco background, I kind of like to see the configuration and just kind of have it hidden behind an extra command to show configuration groups, and kind of having it inherit and kind of behave in a way that's not kind of a one-to-one behavior where it can be applied across multiple aspects of the configuration is something that kind of I'm not super comfortable with, and kind of leads me to feel a little less secure about kind of what I'm doing on the device and what will happen based on what I do. So it's something I kind of have been shying away from, but I think there are definitely situations where using an apply group is a really good idea. So let's see what our options are under here. I think we checked it before. We've got some optional options. Let's get the description for key, authentication element configuration. So now we need to give it this identifier 0 through 63. So that's in the Wireshark capture. We're going to see that assigned 1 hexadecimal digit in the packet, because if you have 4 bits, you get 64 possible values, 0 through 63. So, yep, because you get 2, 4, 8, 16, 64. Yep, 63. So, yep, that's correct. Now we're going to select authentication element identifier 0, see what we got available. Options, secret, start time, algorithm. Let's go with secret. So secret's going to be authentication key. So now this is the actual secret code that we're going to be using to exchange, that the other router is going to need to know. So this is where you would type open sesame or some secret code that, of course, you want to. But remember that these are ASCII characters too, so you can't get too complex with it. You can't have anything that's not a ASCII character, like something that would have to be a Unicode character. You cannot include in this secret. So it looks like the example. This is the secret password. All right, so now we'll need to set up a start time for this. And let's do a show system. So run show system time or date, or just try to find the current time on the system. Clock, show clock. So I actually don't know what the command for this is, but this is why it's important to really get used to using that question mark, because I kind of have an idea for what it might be. Probably under system. And of course, there can be commands that just completely throw you for a loop. But here you can see this command's good enough. So it had the word time in it. You know, you might have to run the command show version to see the time, and you know, the help menu is really not going to help you that much there if you don't kind of already know the eccentricities of the command line. But here we can see it has the word time in it. It's uptime, but it shows the current time as well as the uptime. So this is a pretty useful command. Let's go ahead and stray from the documentation and have this apply it 5 minutes later. So we're going to go with 55 UTC. So set key 0 start time. We're going to do 2020, and then it's going to be, and one thing I can do as well is do this command again, and now filter out for that current time. And I get a much cleaner output to look for, and I can get rid of my scroll back buffer, and there we go. So this is much easier to look at. Something I always advocate that people do is just kind of clear up the clutter from their screen and make sure that what they're looking at is not full of things that they're not meant to look at, because that can really make things harder. And it looks like this last section, I'm not sure what this is. Looks like just an aspect of UTC, maybe the time zone or something like that, but we'll just, looks like we don't even have that listed here, so I'm not quite sure what to include there, but let's just go with what's in the documentation, and hopefully that is good enough. So let's set the other key, set key 1, secret. This is another secret SEC RET password. Set key 1 start time. And let's start that another 5 minutes later. So we can just copy this. And then do it at, let's do 4 minutes later so I don't have to change the first digits. All right, so the start time of each key must be unique within the keychain. That makes sense. You can't have keys that are started at the same time. Looks like you can have the length at which they're active overlapped though. So let's do the, let's apply the authentication keychain to BGP and set the hashing algorithm. Edit protocols BGP, whoops, top, edit protocols BGP group EXT, set authentication key chain BGP auth, set authentication algorithm MD5. So let's go back a little bit more slowly and see what other options we have. So we have all kinds of options, keychain, key. So it looks like we could just set up a plain old, we've got a shortcut basically. Yes, we can create a keychain, and in that keychain we can have different kinds of keys and stuff, but we can just do a direct key without the keychain, it looks like. So let's see what it says for the keychain. Keychain name. So already entered that in. Let's see what it says for authentication algorithm. Oops. So authentication algorithm name. Let's see what options we've got. Hopefully it matches the documentation. Yep. So we've got cipher-based message authentication code. We've got hash-based message authentication code, and we've got message digest 5. So we went with MD5. Yep, so now let's set the, let's go ahead and enter in the optional parts. Let's take a look at the what we got here. So this looks familiar. Let's see. So clock skew, that's what it says. Clock skew tolerance in seconds. I'm going to set that for 30 seconds and commit that. Oh, and it looks like the referenced keychain must be defined. So it looks like the, oh, yep. See, this is a common typo I do. BPG. It's actually going to be BGP. So that's just a typo there. Easy to fix, easy to identify, easy to fix. Those are kind of the mistakes I prefer, the ones that are just simple, easy ones. So, yep, we just need to delete this and then spell that correctly. Maybe it'll auto-complete. No, it won't. Right, so now this will commit. Let's do a show or monitor start messages, and maybe we'll get some sort of syslog message once it goes into effect. It could be expired by now in the time it took me to configure it. Yep, so but I have one set up to go at 59, so we might see that in the middle of our verification. So let's do that right now. We're going to do show protocols. So got to be in config mode to do that. Show protocols. Everything looks good here. Type external. Authentication algorithm, authentication keychain. Spelled right, BGP. Neighbor AS, neighbor. Now we've got, take a look at the routing options. That looks right. Take a look at security. Okay, everything looks good. It looks like their secret is in plain text. Mine's in, well, looks like they just abbreviated what it's going to look like. They didn't want to put out the whole hash on there. So this isn't exactly what you'll see, or you might if you're on a different version, but mine looks good. So I entered the commit, so let's go ahead and do the verification commands. So here we can see they've got an established, but if we go ahead and do show BGP neighbor, ours is going to be active, or sorry, ours is going to be idle. It's not even able to go into active. So, and that's because we don't have that other side set up. So let's go ahead and take care of that. Let's take a look at the system uptime. And it looks like it's going to change over to 59. So let's see if we get a syslog message when that happens. And I actually remember that I set it up to 59:45. So let's wait another 45 seconds and see if we get a syslog message. But until then, let's get the configuration ready to go on the other side. Well, it's just getting close. I guess I have time to pull up Notepad++. It's getting there, so I have some more time. I'm going to change this to here. It's going to be this, and then this is going to be flipped. And this is going to be 2.2. So probably getting close. Oh, and we passed it. So unfortunately, there was no syslog message, anything like that, saying that the key went into place. Probably makes sense because BGP is in idle state. I mean, it would make sense that it wouldn't successfully trigger. And then, I mean, it'd be nice if you get like an error message or something, but let's go ahead and do a monitor stop. Messages. And get the other side figured out, configured. So we can see here we're going to need to configure, oh, that's interesting. I've got ports 1 and ports 0 up, even though I don't have anything plugged into port 1. It's just kind of the eccentricities of using a VM. Let's go ahead and configure port 0. Oops. So you can see what's the issue here. 3, 2, 1. So you actually can't put a IP address on a physical interface unless you set the encapsulation to allow you to do that. But by default, you have to go into a logical unit. So we'll use unit 0. Oops, and it's going to be .16.2.2. And we can use a /30. We only need 2 host addresses. Use a /31 as well, but I think a /30 will be fine. We don't need to conserve anything, just in the lab. So commit that. And now keep working on the config for the other side. And this is something you'll see when you're on the job. It happens a lot too. Really just going and figuring out, you know, what do I need to enter on the CLI is really something that's not, especially when you're working on Cisco's and it automatically goes into running config. You're really going to want to figure it out in a more safe location first, such as Notepad++, and not just immediately jump into the CLI for configuration until you have a better sense of what you need to configure. So everything here I think looks good. Let's drop this in there and then move on. Well, let's include the configuration for the interface. All right, and hopefully this will go fine, and we'll see that BGP membership go into established. Before I commit it, I'll bring up a Wireshark capture so we can see that transition. You can see I forgot the unit 0 again, but that will be fine. Perfect. So you'll see this happen a lot in Juniper's too. It doesn't take all of your configuration, or at least just in a lab that happens. But I find Juniper is just copying, pasting in large blocks of configuration kind of don't handle that as well, which is kind of ironic because this is the type of device where it's safe to do that because it just goes into candidate config, and Cisco's it's really unsafe to do that because it goes right into the running config, but that seems to happen more easily, which is kind of ironic. So let's see if I can get this to commit. So set security keychains. Keychain BGP, I don't see where that command was entered. Let's just do this again. And just start here. Perfect. And then go down to here. All right, looks good. Now let's do the next 3 lines. All right, and the final 2 lines. Perfect. So hopefully this will commit. Oh, and I forgot to bring up that Wireshark capture. Hopefully it's not too late. If it is, we can always roll it back. In fact, let's go ahead and do that. Just roll it back and then recommit it so that we can see what shows up in that Wireshark capture. So right now it's going to be just a dead link since there's no IP address on there. Nothing's going to show up. Sure enough. So once I commit that, there's going to be a lot more traffic. And afterwards, when I filter it out for BGP, we'll be able to see that three-way handshake, and hopefully we'll be able to see the keys being exchanged. And we're going to see two three-way handshakes, one initiated on both routers, one for each handshake initiated on each router. So it looks like we're getting a lot of TCP SYNs, and it's coming from .1. So .1 seems to be up, but .2 seems to be not ready to respond to those SYNs. So let's take a look at which one is .2. So R0, which is .1, seems to be sending SYNs over to R1, but R1 is not responding back. So yep, because R1 has .2.2. So there might be some kind of issue where R1 cannot respond back to R2. Let's take a look at the BGP summary. So it's stuck inactive, and it's trying to form neighborship with R1, which is great because this is R2. And this is trying to form with R2, which is great because this is R1. But let's look further into the configuration. One thing we can do is go ahead and ping the neighbor 16.2.1. Yep, and looks like there's no issue with that. There's just an issue with it being able to respond. One thing I'm surprised I'm not seeing is any, well, I mean, you're not gonna see any BGP messages exchanged unless there's a proper TCP handshake first. And it looks like right now there's no possibility of that happening because only router 1 is able to send traffic to router 2, but router 0 with the .1, but router 1 with .2 is unable to respond for some reason. Let's try to figure that out. Why is R1 unable to respond to R0 through TCP, even though a ping is working? So yep, a ping is perfectly fine, but forming an actual three-way handshake, that's not fine. And I would think that the authentication all happens after the three-way handshake, so you could form the handshake, but unfortunately you could not establish the neighborship because it would fail authentication. But we can of course test that just by deleting all of the configuration that has to do with the authentication. And we can leave it all configured globally because it doesn't do anything unless it's actually applied somewhere. So let's go into Edit Protocols BGP Group EXT, and let's delete where the keychain is actually applied. And commit that. We'll probably need to do it on the other side as well. All right, and hopefully there's some differences in the Wireshark capture, but I really wouldn't expect there to be because the issue is with the three-way handshake, and I would expect the authentication to occur after that. But another thing we can do is just restart the capture, because as was seen in previous videos, it can kind of just stop without any notice. Let's do that. And hopefully we'll see that TCP traffic again, although I really don't see it now, which is interesting. Oh, here it is. And we're getting BGP keep alive messages. So yeah, it looks like there was an issue with having that authentication on there. Yep, so now we've got an established state by having that on there. So I bet you if I go ahead and delete that, we're going to see this go down back to active state. So if I delete the configurations and what I mean to say, but if I roll back and then reapply it to the interface, now the BGP neighborship will go back into active. So it's going to do a four-way disconnect. FINAC, ACK, FINAC, ACK. That's the four-way disconnect. Then now router 0 is going to go back to responding to R2, but R2 is not going to respond back because that authentication is not being properly satisfied, which is interesting because I would have thought that in order to authenticate BGP, you'd have to, like, it wouldn't prevent the three-way handshake from forming. It would prevent just the BGP communication from happening properly. But you can see pretty clearly, and perhaps this is the password, but in any case, it's pretty clear to see that you do need to have that authentication working even to establish the three-way handshake, which is, I think, better news because that's much more secure. That's kind of the way I would want it to work. But let's try to get this working. So let's just set up the simplest and most basic authentication that we can. So we're going to look at the configuration. Oops, display sets. And now just wipe off all the security. And we're going to need to wipe off this as well. I think another thing you can do is show pipe display. No, can't do that. I thought you could do like a show pipe display delete and just double click them in there, but you can only do a display set. So let's delete this one. And now this is all stripped down without the BGP authentication. So we'll see this reestablish. with another three-way handshake. We'll see a SYN, SYNAC, ACK, and we'll see 6 packets associated with that, 3 for the connection originating on R0 and 3 for the connection originating on R1. So let's clean up R1. Okay, so let's see those handshakes. Oh, so it's an open sent, so it's very, oh, and now it's an established. Ah, here we go. So it's just a little bit slow to populate. It all kind of populated at once. Well, actually, never mind. It just skipped up to the top. You can see that it has only collected 21 packets, so there's going to be many more than that. So we can see that the capture froze, stopped collecting new packets, which can often happen. But luckily, it can just be restarted. So let's go ahead and drop that connection to a rollback 1 commit. And now it's going to go back into active. It's not going to be an idle, it's going to be an active. If it were an idle, it'd be because it couldn't even use, like there'd be no IP address on the interface. It'd be a much different situation if it were an idle. But we can put it in established. And get that 3-way handshake. So it is an idle, so we're going to get, we're going to get TCP packets. It's only going to be sent from R0 to R1. R1 is not going to send them out until we do a commit. There we go. So I'll stop the capture. And we'll look at the 2 sets of 3-way handshakes. So you can see it's doing a lot of SYNs to try to get a SYNAC back, but it doesn't get back a SYNAC until here. And then it exchanges open. So let's go ahead and filter out for that on this first SYN here. SYN, SYNAC, ACK, followed by a BGP open message. With lots of optional parameters. I don't see anything on authentication, but probably just because we haven't enabled it. I guess I'm wondering if there's like a blank authentication, if it's included and shows information about it, even though it's not enabled. But I don't see anything like that. Yep, nothing like that. One thing I also am noticing, just kind of something I didn't expect, is I don't see the other 3-way handshake from the other side. I'm expecting to see a SYN from .2 and then a SYNAC from .1, but I don't see that. So it's kind of interesting that it behaved a lot differently. And it could be just an eccentricity of the actual, the fact that it's a VM, something like that. You're always going to have little blips if you're using VMs, but unfortunately, getting your hands on real gear is sometimes not possible. So I think I'm going to end the video there. I kind of need a break. It's going a bit long. So we looked into BGP authentication. We configured it exactly as the example said. We use different start times, different UTC, but we can see we had trouble getting that to work. So the next video is just going to be devoted purely to troubleshooting and making sure that works. Hope you enjoy it.